Fortigate NAT types. In a typical FortiGate, we have three main NAT types. NAT allows a router to modify a layer 3 packet and change the IP addresses either for the source or the destination IP address. First, we have NAT using Algon interface, and this mode is suitable for connecting to the internet. So your ISP will give you a single IP address, public IP address, and all your internal clients will use their private IP addresses to try to access the internet. And then the firewall or your router will take all these sessions and NAT it using a source NAT to a specific public IP address that is assigned to you. And when the traffic gets a response back from the end or the destination, the firewall will do a reverse NAT and send the response back to the original sending client on their private IP address. So the firewall maintains a table for NAT that says this client came from this private IP address using this source port, and he tried to access google.com on port 80 or port 443. So I'm gonna leave that inside and I'm gonna wait for a response from google.com, and once the response comes back, I will send it to the private IP address. This is suitable for internet access for small sized offices because the single IP address can only handle so many sessions. Therefore, your second option using a NAT IP pool, and the IP pool contains more than just a single public IP, maybe a bunch of public IP addresses from your ISP, or maybe you have a whole subnet of public IP addresses that is assigned to you. This way you can use overload source NAT using an IP pool to distribute the sessions from your clients into those multiple public IP addresses, and will have a lot more capacity than just a single IP address. Also, you can use IP pool to make a one-to-one source NAT using a specific IP address, so you can just do a specific matching between a source IP address and another source IP address, and the firewall will do all the work of doing the NAT and the reverse NAT, and will make sure this traffic can move in between those IP addresses. Also, one-on-one pools, often used to route overlapping IPs on different subnets. If you are using the NAT on the source device, then you will be using an IP pool. And finally, the virtual IP we use to translate the destination IP address into another IP address. So it's a direct one-to-one NAT, and it's suitable for port forwarding and conflicting IP addresses as well. So for conflicting IP addresses, you can either use a source IP NAT or a destination IP NAT. Just you have to find a NAT solution to be able to route overlapping IP addresses. So first, let's test out our NAT using Algon interface IP address. And this we will be using to configure our internet access on those devices. As we see, we have a Windows client on this subnet, and if we try to access the internet, we still cannot access the internet on this firewall. Let's take a look at our original site, and let's look into our log and report. Under log and report, we will see that all the traffic coming from our internal subnet going to port 1, which is the internet, is being denied. So we need to configure our internet access policy in here because we have no firewall policies as of now to allow access to the internet. So let's build our policy to the internet. I choose all my internal subnets as the incoming interface, and the outgoing interface will be our internet port. We will leave the source and destination IP addresses open, and we're just gonna allow ping, DNS, and web access. In this case, we will be allowing the NAT using the outgoing interface IP address. Therefore, all my internal clients coming from all these different subnets will be NATed to the internet IP address 192.168.1.121 or your real public IP address. And this is because it's using the outgoing interface IP address NAT. And then when the response comes back from the internet, the firewall will do a lookup on its NAT table and then will do a reverse NAT and send the response back to the internal client on their private IP address. So we will leave the option to use Algon interface IP address. And in case you're wondering, this is the dynamic IP pool option. If you have a lot of session or if you are working on a bigger enterprise, you can put a /24 or a bigger subnet than just a single IP to allow more density and more capacity for your internet users. But for this specific lab, we just need that specific IP and allow all sessions to be logged and then save our policy. And now I will have my first internet access policy in here. So now if I go back to my Windows host, I'm now able to access the internet using this policy. If I try to refresh the page, now I see already 12 megabyte hits on this policy because probably the Windows will try to install updates and things like that, and therefore there is already a lot of traffic on this policy. And that's how you use Algon interface IP address to get access to the internet. So now let's see how we can use this NAT pool at the original site to route traffic to conflicting IP addresses in the new site without having to add any additional routes or anything of this sort. We will be using the virtual IP feature to create a destination NAT to allow this traffic to go through, and the firewall will do all the work of changing the IP addresses on the fly. Let's go into our new site, create a new policy, and this time we're going to be coming from our VPN, going into our sales, because this is where the subnet, the conflicting subnet is, and the source will be all the addresses on the other side of the VPN. For the destination, we need to create a new virtual IP. This is the destination NAT feature on the firewall, and we're just gonna call this conflict because this IP address is being used on both sides, and I want to use the first IP address from 172.18.0.193. This is the small chunk of the subnet that I designated for NAT, and every time someone hits this IP address, the firewall will reverse, or the firewall will NAT this traffic to 10.10.100.2 and vice versa. So now my virtual IP object is here, and for the service I want to allow Bing, and for this it's vital to enable NAT because without NAT the source IP address and destination IP address will be the same, and it will not help us fix the problem eventually. So the NAT must be enabled in this policy, and we want to log all sessions and save. And now I have my policy coming from VPN into sales department where they have a conflicting IP address. And now it's time to test our new virtual IP. I want to come into this link and I want to capture the traffic on this interface to see the traffic as it goes. And I want to come to one of my design PCs. And on the design PC, if I try to ping 172.18.0.193, I will be able to ping the host on the other side with the conflicting IP address, even though I'm addressing it using this intermediary NAT IP. And this way we are able to route traffic between conflicting IP addresses using virtual IP feature of the Fortigate. Thank you for watching.